Hello, guys. Good evening to all. So, Thomas, Joseph, and Pradeep. Good evening, guys.
Good evening.
Yeah.
Good evening, sir.
So, hope you can hear me, and I hope you can see the whiteboard.
Yes, sir.
Can you see the shared screen, everyone?
Yes, sir.
Yeah. Okay. Great then. Okay. So just wait. Let's wait for another and see if anybody joins. Okay. So hope everyone knows that today's topic is about the exponents. Okay. So we'll discuss the basics, then the rules, then the laws, these questions of exponents. Let me share the presentation first. So exponents. So exponents, in a sense, the number power something, isn't it? So which means a number is multiplied by the exponent times. So that the exponent can be any number. So the exponents are also called as the powers or indices. So I hope you guys know, aware of what is exponent. So exponent is the number which says how many times we need to use the base number in a multiplication. For example, you can see there in 2 power 4, 2 power 4. So 4 is the exponent there. So let me share the whiteboard and explain a bit more in this. Yeah, this exponent. So let's say x power n. Let's call it as x power n. So what does it mean? Where x is the base, okay? X is called as a base and n is called as exponent. And this n we also call the exponent as power, or else we can say indices, index, generally index if it is 1, okay? Index or indices. Okay, so this is the other name of exponents. I hope everyone understands the base, the difference between the base and exponent. So you might get a question saying that in a question called 5 power 9, what is base? What is the base of 5 power 9? The base is 5 and the exponent or a power is 9. Hope everyone understands that. So for example, if we take another example such as 3 power minus 5, what is the base here? The base is 3, and then the exponent, what we have in the exponent? We have a negative exponent here, you can see that. So we need to write minus 5 as an exponent, okay? If we get a question, what is the base of a number or an exponent of a number? Then, for example, minus 5 power 7. In this case, what will happen? So what is the base in this number? The base is 5. I mean minus 5. We have a negative 5 as you see. Exponent is just a 7. I hope everyone understand the difference between the base and the exponent. So this is a very important one. I mean, before we go to the properties or rules of exponents. So if we have a negative number in a base, that becomes a negative. For example, what if we have a both negative? For example, I'm writing left corner, I mean bottom left corner, minus 5 power minus 3. Here, The base is the negative 5, okay, the minus 5. The exponent is minus 3. Okay, so I hope everyone understand this. Let's go to the PPT again and see. So how do we read the exponent as? So you can see that in words, how do we read exponent? 2 power 4. So 2 over 4, we generally, we read that as 2 to the 4th power, or else 2 to the power 4, or else 2 to the 4th. So we can say in any of the form, right? So let's use like 2 to the power 4. And please read the last sentence in this. So we can multiply any number by itself as many times as we want using the exponent, based on the exponent. For example, if we have a question as 4 power 6, we need to multiply, which is 4, by 6 times. I hope this everyone knows. Okay, let's go to the whiteboard and let me explain a bit more. Okay. Show me. Yep. So how do you, so in this, in questions, we might have a simplification, or a solving. Simplification, we are just simplifying the question, not solving. We can't solve that though. Solving, in a sense, finding the exact answer. Okay, so let me explain a bit more in this. For if the question is solve 4 power 4, what is 4 power 4? 4 times 4 times 4 times 4, isn't it? So then we just need to multiply all the numbers to get the answer. So 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. So 4 power 4, the answer of 4 power 4 is 256. Hope everyone able to follow me though. Okay. So this is nothing but a solving the questions where we are going to find the exact value. Simplification, in a sense. Simplification in a sense. For example, we have a x power 5 times x power 3. So we are going to simplify this because x is a variable, is a letter, isn't it? So we are going to simplify that into a lowest term. So I will explain all those things. So before that, let's have a look at the rules. Yeah. So what if we have a negative exponent? You might have a question. Okay. Negative exponent, in a sense, we just need to flip the fraction or flip the exponent, you can call it as. So it's kind of a reciprocal. Okay, let me explain few examples so that you will get an idea. So generally speaking, okay, I got a chart. Yeah, good evening. Yeah, okay. So 4 square, so or rather 2 power 4. How do you solve this question? We are just going to multiply, isn't it? So 2 times 2 times 2 times 2. What is the answer? We'll get 4, 8, and 16. So if the same thing as in a negative exponent like this, yeah. So 2 power minus 4. You can see that we have a negative exponent. So how to solve that? So we are going to convert that into a positive exponent, because whenever we are writing the answers, make sure that the exponent must be positive. I'm repeating again. Whenever we are writing the final answer, the exponents must be a positive. So what is a basic rule? Let me write the rule for this. If you have a negative exponent, for example, x power minus n. So minus n is the exponent. What will happen? This goes to the denominator, which is nothing but 1 divided by x power n. So x power n, if it goes to the denominator, minus n becomes a plus n. So that's what here. 2 power minus 4 becomes 1 divided by 2 power plus 4. I hope you are able to follow me. Then solve as it is, which is 2 times 2 times 2 times 2 in the denominator. Okay, so which is 1 over 16. If you want to write the answer in fraction, this is the answer. If you want to write the answer in the decimals, you might need to simplify, where we might ended up getting a recurring decimals. So, but not in this case. But I think it's more than enough. Just write the answer in fraction. That's more than enough. Hope you guys understand. So how to solve the negative exponent questions. Let's try a few more questions in this. So let's say, how do you solve minus 2 power 7? How do you solve minus 2 power 7? So here the base is minus 2, the exponent is 7. So we are going to multiply the base number, which is minus 2, by 7 times. So minus 2 times, minus 2 times, minus 2 times, and it goes on for 7 times. I hope I have written 1, 2, 3, 6, 7 times. So this is how, okay? If the base is negative number, we need to include negative number in each of the base while multiplying. And everyone knows base of, I mean, the multiplication of a negative number. If we are multiplying by even times, for example, 2 times or 4 times or 6 times or 8 times, we'll get a positive answer. So let me explain that first. So what I mean to say, minus 5 square, so which is minus 5 into minus 5. Minus of minus. If you multiply the negative sign twice, we'll get a positive, isn't it? Similarly, if we have a minus 5 power 4, so here the exponent is 4. The reason we are multiplying the base number 4 times. So we will get 4 negatives. So the answer will be in a positive. So here, but in this question, 2 minus 2 power 7, we have an odd number, 2 power 7, right? See, this 2 becomes 4. This 2 becomes 4. Minus 2 times minus 2, 4. And then this 2, minus 2 times minus 2 becomes a 4. And finally, we're left with 1 minus 2. So one negative number. So try and multiply again. So 4 times 4 is 16. 16 times 4 is 64, isn't it? So finally, we left with 64 times minus 2. So one positive number, one negative number. So 64 times 2 is 128. So here we have a minus 2. So minus 28 is the answer. I hope everyone understands this. Let's try one more question though. For example, minus 3 power of 4. What will happen to this? We are going to multiply the base number minus 3. Since we have an exponent as 4, we are going to multiply the same number 4 times, which is minus 3 times, minus 3 times, minus 3 times, minus 3, like that, like this. So then you're going to multiply. So what are the ways to multiply? See, you can multiply these two, get the answer, which is 9. Then multiply with the next number. What is the answer? Minus 27 times a 3 times minus 3. We'll get plus 81. So this is one way of doing, okay? So if you're confident, or if you want to try in another way, so we can try this way. which is multiply the first two numbers, what will get plus 9, isn't it? And then multiply the next two numbers, again we'll get the 9. So what is 9 times 9? Plus 9 times plus 9, which is obviously 81. So we'll ended up getting the same answers. So you can continue from the left to right, goes on multiplying, or else you can multiply two numbers and finally you multiply those answers. You will find the answer. See why we got the answer is positive here. I hope everyone understand the reason. The reason is we have a even exponent. For example, if we have a minus 5 over 3, which is minus 5 cube, what will happen? Minus 5 times minus 5 times minus 5. So if you multiply this two, the first two numbers will get plus 25. 25 times minus 5 will get minus 125. So the reason is we have an odd exponent. So that's why we will get the answer as negative, answer in negative. Hope everyone understand this. So please feel free to ask me if you have any questions, okay? In between the class, it's fine. You can also ask me the questions on the chat. Okay. So what's the next? So you might have one more type of questions. For example, so we learned both base and the exponent are positive. We learned only exponent is negative, and we learned the base is negative, like this. So we learned all these three types. So what if we have both base and exponent as a negative? For example, like this. What is minus 2 power minus 5? So first of all, you are going to convert the exponent to a positive. So make sure that whenever you get a question in exponents, so try to convert the exponent to a positive. So which is 1 divided by minus 2 power 5. I hope everyone understands this. Then we have a minus 2 power 5 in the denominator. So just multiply minus 2 5 times in the denominator. So like this. So and see how much we get. 2 2s are 4, 4 16, 32, isn't it? Let me check it again. 4, yeah, 32. So, but since we have a odd exponent, we'll get an answer in negative. So 1 divided by negative 32, which is nothing but the answer you need to write minus 1 over 32. So because we are going to write the negative sign in front of a fraction, right? Most of the times. That's why. Hope everyone understand this though. So that's it of the basics of exponents. I hope everyone understand the basics. So now we are going to learn the rules of exponents. Okay. So before that, let's try one more. Minus 3 power minus 2. What is the answer for this? First, convert this into a positive exponent. 1 divided by minus 3 power 2. See what I did? Minus 2 becomes plus 2 if it goes to the denominator. So that's the only thing I did, okay? It's kind of a flip the fraction or a reciprocal of the number, okay? Then minus 3 square, which is minus 3 times minus 3. So we'll get minus 3 times minus 3 is 9, right? So 1 over 9. So that's the answer. I hope everyone understands this. Okay. Let me share the PPT with you guys. Yeah, and you can see the negative exponent 4 power minus 2 becomes 1 divided by 4 square. 10 power minus 3 becomes 1 divided by 10 power 3. Yeah, so that's what I have explained so far though. Okay, so then the rules now. Let's go to the rules. So instead of showing in a PPT, let me write and explain, so that make little easier to understand. Okay, what about the rules? Exponent rules, you can call it as. So let's start with the basics. So we can use, I mean, I am going to use a variable as x, okay? That x is nothing but a base. It can be a or any number. So that doesn't matter, isn't it? Okay, just a minute. So what is x power 1? So this is the first rule. What is x power 1? Which is nothing but any number power 1. Any number power. X can be any number, isn't it? So x power 1. So any number power 1 is always the number, the original number. For example, minus 2 power 1. The answer is minus 2. So I hope everyone knows this. This is the basic exponent rule. The second one, x power 0, which is nothing but any number power 0. I'm repeating, any number power 0. So which means any number, 5 power 0, minus 6 power 0, or any number, 100 power 0. So what is the value for any number power 0? So which is x power 0. So any number power 0 is always 1, not 0, or not a number. For example, even 1000 power 0 becomes a 1. Okay? So, I mean, so don't confuse with 1. So if power 1 will get a original number. X power 0, any number power 0 is always 1. It can be any number. It can be a negative number or it can be a positive number. That doesn't matter. I hope everyone understands that. What's the next thing? The third one. I think I already explained the third one, which is a negative exponent. What if we have a negative exponent? X power minus n. So where n or a minus n is the exponent. X is a base, isn't it? So x power minus 1 turns to positive. How? X power 1 divided by x power n. I hope you guys understand this though. I have already explained this. Okay, what is the fourth rule? So these are the basic, the first three, and then now we are going to learn the exponent rule for multiplication. X power m times, so I'm using the times symbol as a start here. Yeah, x power n. So if you're, see, what is the difference between x power m times x power n? What is this? You can see that the bases are same. Okay, so the bases are same, which is x, but exponents are different. Okay, so for example, 4 square times 4 cubed. What do you mean by this? 4 is the base in both the occasions, but exponent differs. Okay, so what we do in that case? So when we are multiplying the exponent numbers like this, keep the base as it is, add the exponents. Hope that makes sense to everyone. Please feel free to ask me, I mean, if you have any questions. So if you are multiplying, or rather while multiplying exponents with same bases, we need to keep the base as it is, but we need to add the exponent. What about the fifth one? Similarly, if we have a division, x power m divided by x power n. For example, 4 power 9 divided by 4 power 3. So what we do here, so we'll keep the, so I mean, if you want to convert this 4, I mean, if you want to move this denominator to the numerator, what will happen? X power m times x power n becomes minus n. So here 4 power 9 times 4 power minus 3, because we moved the denominator one to the numerator. So which means the exponent sign will change, isn't it? So and then solve. what will happen? So the same thing, x power m minus n. We are going to add the exponents when we are multiplying, but we are going to subtract the exponents when we are dividing. I hope you guys understand that rule. So, and please let me know if I'm going too slow. So you might know these rules. I will try to teach faster in that case. So I'm just assuming you are learning these things first. That's why the first time. Okay. So what is the next rule? So we learned, we learned the basic three, then the multiplication, now the division. Now, see, x power m, this is nothing but exponent of exponent, kind of. So you can see that x power m whole power n. So how the question looks like? You want me to give an example? 6 square whole power 3, 6 power 2 whole power 3. So how this works? We just need to multiply both the exponents. That's it. X power m times n. So I'm writing as mn. So which is nothing but m times n. Okay. So that's fine, I think. So I think we'll go to some questions. So we'll get an idea though. Okay. Okay, and one more rule. For example, we have two different numbers, x, y. X is different number, y is different number. Whole power n, or a m if you want to take. So in this case, we are going to distribute for each one, x power n and y power n. Okay. So I'm just distributing. See, this n applies to, this exponent n applies to x as well as y. Hope you guys understand that as well. Similarly, if we have a division form, x divided by y whole power n, x power n divided by y power n. Hope you guys understand that. I think these are the final rules. I think that's it. These 8 are the important rules. We do have a fraction rule or a square root rule. So I will explain later in the class. So let's solve some questions using all these rules. I mean, you guys are open to interact. So that would be a good idea though. If you want to say the answer, you can interact. Okay, so let's try some questions. 4 power 9 divided by 4 power 9 times 4 power 2. See, we need to multiply these fractions. No need to solve, just simplify. Okay, so you can see the base as 4. So 4. Since we have different exponents, this called as a m, this called as a n. So what we'll do? So we are going to add the exponents, isn't it? So 9 plus 2. So which is 4 power 11. So whenever we multiplies, we're going to add. Yes, good, Joseph. Okay, so then 9 power 2 divided by 9 power 7. What we do in this case? 9 power 2 minus 7. So we are going to subtract since we are dividing. Okay. So what is 9 power, 2 minus 7? 2 minus 7 is minus 5, right? But I already told you, whenever we are writing the answer, make sure to write the answer in a positive exponent. So you're going to turn this back into a positive, which is 9 power 5. Hope you understand that. And you can ask me why we are not simplifying or solving this. The reason, it will get a bigger answers. Okay, 4 power 11. Just think, we need to multiply 4 by 11 times. So we'll get a bigger answer, maybe a 4-digit or a 5-digit answer. That's why. Just keep it as it is. Simplify this, more than enough. Okay, so let's go to the next one. 9 square times 9 power 5 divided by 9 power 3. So how do you solve this? We are going to use both the multiplication and division rule here. What do you mean? What I mean to say, just combine the numerators together. What will happen? 7, 2 plus 5. So this is 2, this is 5. 2 plus 5 is 7. So 9 over 7, 9 power 7 divided by 9 power 3. Then use the division. 9 power 7 minus 3, which is 9 power 4. Hope you guys understand that. So I will repeat if required. Just please let me know if you want to repeat again. Any time is fine. You can just interrupt me and you can ask me the questions if you have any. Okay, let's try one more. 2 power 5, 2 power minus 3 divided by 2 power of 4. What we do in this case? So are we going to simplify the numerator first? We can do that, which is 2 power 5 minus 3, isn't it? Divided by 2 power 4, which is 2 power 2 divided by 2 power 4. And you can do here, you can, or else if you are confident, you can directly write the answer as 1 divided by 2 square. Or else use the formula 2 power 2 minus 4. Why minus 4? Since we are dividing the exponents, the values. So we'll get 2 power minus 2. Finally it simplifies to 1 divided by minus t. I hope we used some rules here, at least 3. Let's try and use the remaining. Okay, so how do you simplify this? How do you simplify, or rather, how do you solve this question? So, the question will be like a simplify, or else solve, or else simplify and write the answer in an exponent, in exponent form. Write the answer in exponent form. Okay, so these are the 3 types of questions you might get. Exponent form. First one is simplify the question, or solve the question, or else simplify and write the answer in exponent form. Okay, so how to solve this question? So 4 square times, what is 4 power 0? Anything power 0. What is anything power 0? Is 1, right? Times 4 cube. So then you can say 4 power 2 plus 3, which is 4 power 5. You can just leave it as if it is simplify. If they ask the question as a solve this question, then you need to multiply this 5 times. Okay, so that's the difference between a simplification or a solving. Solving, in a sense, you need to write the final answer or the complete answer as an integer, as a whole number. But if it is a simplify, you can just write the answer in an exponent form. That's fine. So what is 4 power 5? I think okay, so 16, 512, 512 and 1024, it seems. Yeah, 1024. So that's the final answer. Okay. So 4 times Okay, 4 square, 3 square, whole power 0. So please have a look at this question carefully. 4 square times, obviously, 3 square, whole power 0, whole power 0. So how do you solve this? Are you going to, I mean, if you want to write the answer directly, you can write. But if you want to solve the question, you can go ahead and solve. But how? Because I already told you anything power 0, anything power 0 is 1. So no need to solve this question. You can just write the answer as a 1 here. Okay? If you want to solve, you can do that. Again, 16, 4 square is 16, and 3 square is, what is that, 9. What is
144.
Yeah, 144 power 0. We have a 0 on the top, right? So what is 144 power 0, which is 1? I hope you understand. I hope you guys understand that. So let's go to the rules again. Let me show you the rules. Just have a look at the rules. X power 1, x power 0 is 1. The negative exponent, what will happen? It will go to the denominator, right? And whenever you multiplying the exponents, we need to add. While dividing, we need to subtract. And the next three, I will explain now. Okay, let's take the question as simplify rather solve. Yeah, both are fine anyway. 4 square whole power 4. So how do you solve this? What the rule says? We just need to multiply the exponents. 4, 2 times 4. What is 2 times 4? 8. So that's the answer. No need to find the answer though. Let's just leave as it is. So that's fine. So let's try one more question. 2 power minus 3 whole power 6. So how do you simplify this? Are you going to convert this into the positive exponent first? No. First, we are going to multiply. Okay. So which is 2 power minus 3 times 6, which is minus 18, right? And then you're going to convert 1 over 2 power 18. That's it. That's the answer. Hope you guys understand that. And the next one, for example, let's take a variable such as x, y whole power 3. So how do you simplify this? You're going to write separately, right? So this exponent 3 is applicable for both x and y. So you're going to write x cube and y cube. So as simple as that. So similarly, if we have a question, x square y power 3 z whole power 5, let's say 5. So how do you simplify this question? So you are going to use this this exponent to each of the variable, isn't it? So x power 2 times 5, x power 2 times 5. What is x power 2 times 5? 10. Y power 3 times 5, which is 15, and z power 5. Because what do you mean by a z? Z is nothing but a z power 1, right? That's what we learned. Anything power 1 is same. So that's why we are not writing we're not going to write 1 as an exponent, right? Because it's there as a 1 if you are not writing the exponent. So that's why z power 1 times 5 is z power 5. So that's the final answer. That's it. So I hope everyone are able to follow me. So what's the next one? So x divided by y whole power 9. So how do you simplify this or expand this? X power 9 divided by y power 9. So for one more question, x power 3 over y square whole cube. How do you solve this question? x, what is 3 times 3? 9 whole divided by, so we have already 2 as an exponent. We are going to multiply 2 and 3 here. So y power 2 times 3, which is 6. That's it. So do you think we can, I mean, can we simplify any further? So can we use a multiplication division rule here, which is nothing but x power m and divided by x power n? Can we use this? We can't use, right? The reason is the bases are not same. So that's where you need to think. Here the x is a base of numerator and y is a base of denominator. So we can't use this rule. We can use this rule only if we have a same basis. So that's it. This is the final answer. Hope you guys understand. Okay, just let me share the PPT and check if I have anything. Yeah. So these are the rules. I think I have explained all the rules. The name of the rules, if you want to read, just have a look at these. So multiplication rule, I already said. In multiplication rule, we are going to add the exponents. In division rule, we are going to subtract the exponents. I think they used x, I mean a here instead of x. That's fine. Power rule, what we use power rule? We are going to multiply the exponents. You can see that. A product rule, I think we did this as well. So we are going to distribute the exponent. The division one, we did that. Zero exponent, anything power 0 is always 1. Negative exponent we tried. And the fractional, I will explain the fraction. So please let me know if you have any questions so far. So we'll try some hard questions, difficult questions now. Anybody has any questions so far? Okay.
No.
Okay, great. So what do you mean by a radical? Have you heard of a word called a radical sign? Okay. A radical is nothing but a root. It is a root. We don't know which root it is. It is a root, okay? So this can be any number. If we have a square root, so how do we use square root? It's a normal way, which means we have a 2 in it. Okay, so that's the square root. Let's say square root of x. What about a cube root? We will have a 3 in it, isn't it? This is the cube root, right? Cube root of x. Add a fourth root. Fourth root. What do you mean by a fourth root? We'll have a 4 in it. Fifth root, we have a 5 in it. Sixth root, we have a 6 in it. So far, I mean, so if we have a 20th root, we have a 20 in it. So that's the thing. So that is nothing but if we have a n can be any number. Okay. So if we have a nth root, so that is we have a n here. I hope everyone are able to follow me. So what do you mean by a square root of x? We can write the square root of x as an exponent, which is 1 by 2. So since 2 is a square, so we are going to write. So what is square? Square of a number? It is nothing but 2 square. So this is the exponent. And the exponent is 2, right? If it is a square. So square root in a sense, just take the reciprocal of that, which is 1 by 2 in the exponent. Okay. So similarly, cube root can be written as an exponent form as 1 over 3. X power 1 over 3. I mean, for example, cube root of 4. How do you write this? Rather, cube root of 64. How do you write this? 64 whole power 1 by 3. Okay. So similarly, fourth root, you are going to write 1 by 4. Fifth root, you are going to write x power 1 by 5. nth root 1 by n. I hope you guys understand the relationship between the roots and the exponents. Okay. So that's how we solve. So I just shown an example here, which is cube root of 64. So how do we solve? I think if you attended the previous webinars, you might know this. But how do we solve this? 4 cube, right? 4 cube is nothing but 64. So cube root of 4 cube. So convert this into an exponent. So 1 by 3. So how do you solve this? Just use the exponent rule. 4 power 3 by 3. We are going to divide, isn't it? We have a 3 into 1 over 3, which is 3 by 3. So 4 power 1. So the answer is 4. That's it. For example, let's take a different root. Let's take a fifth root. Okay. And let's take a number as fifth root of 32. Okay. So what how to solve this? Just find the factors of 32 and see. So 32 is nothing but a 2 power 5. I hope everyone knows that. So which is a fifth root. So convert this into exponent. How do you do that? 1 over 5. So 5 cancel out. 5 over 5, right? So we'll get the answer as 2. Hope you are able to follow me though. Just ask me if you have any questions. So this is the exponent rules we are going to use in a radical signs, radical roots, which is nothing but a roots. It can be a square root, cube root, fourth root, or nth root. It can be. Okay, for example, square or a fourth root of x power 8. So what is the answer for this? It's a very simple calculation. See, x power 8 whole power 1 over 4. So we are going to multiply the exponents. X power 8 divided by 4. Why we divided? We have because we have 1 over 4 as an exponent. So the answer is x square. Hope you guys understand this. Let's say x power 10, y power 25. So how do you simplify this? Fifth root it is. So you're going to keep the numbers, the variables as it is, but you're going to convert the root into an exponent. That's what I did. Then use the exponent rule. Which rule? You might have a question. Which rule? Just have a look at the rules. Just have a look at the rules. The seventh rule. Can you see the seventh rule? So which is the product of numbers. So we are going to multiply the exponents, isn't it? Or else vice versa. It works in both directions. So that's what we are going to do in this question. Yeah, here. So x power 10 whole power 1 over 5, which is, it becomes a 10 over 5. I hope you got that. And y power 25 divided by 5. So what is the answer? Everyone knows that, I hope. So which is x square y power 5. So this is how we need to solve. Okay, let me check if anything is left. Just a moment. Yeah. So these are the laws we already learned. Yeah, so that's it. So we might need to try these questions. So before that, let me explain one more thing. A power of 10. Power as a 10. Power of 10. Or an exponent of 10. Okay. So what is exponent of 10? So what do you mean by, I mean, that is nothing but the base is 10 and the exponent will be something. It can be 3, it can be 5, any number. So why I'm explaining this is, so you might come across the topic called standard form and scientific notation. Scientific notation. When we use the scientific notations for writing the smaller numbers and the bigger numbers in a simpler way. I'm repeating again. To write the bigger numbers and the smaller numbers in a simple way. For example, if we have a number like this, so can we write this as 10 power 1, 2, 3, 4, 5, 6, 7, 10 power 7. So this is the form of a scientific notation. This is how, I mean, this is the scientific notation form, okay? So this is a standard form. Hope you guys got that. Similarly, 0.00 of 5. So how do you write this? A 5 times, how many zeros we have? 1, 2. We need to consider after the decimal point though. 1, 2, 3, 4, 5, 6, which is 10 power minus 6. I hope you know why minus 6, because it is in the left side of a number, and you can see that. You can see the comparison. Okay, so these exponents used in scientific notations as well. Want me to try a few more questions in this? So we'll do that. Let's say 16 maybe a million or something. Okay, let's stop there. Okay, so how do you convert this into a scientific notation? You're going to write obviously 16, then 10 power. How many zeros are there? 1, 2, 3, 4, 5, 6, 7 again. Okay, so that's the answer. 16 into 10 power 7. That's the answer. So this is of converting the standard form to a scientific notation. Hope you guys got that. Yeah. So let's try some questions. 2 power 5 times 4 cube whole power 7. So how do you simplify this? So we are going to, I mean, include or distribute this this exponent for both of the numbers, right? So and then we multiply. So 2 power 5 times 7, 35, times 4 power 3 times 7, 21. Okay. Is it possible to simplify? So maybe I could have, I mean, I will explain the other things. And I hope everyone knows this. I mean, maybe the basics. So that is nothing but 4 square. So here we have a 4 square. Just take a look at this. Can we write 4 as a 2 square? Can we write like this? I hope everyone agrees to this. What I did, 4, we know that 4 can be written as 2 square. So 4 square becomes 2 squares, square of square. So 2 power 2 whole power 2, which means 2 power 4. What I mean to say, 4 square is same as 2 power 4. Let okay. 27 power 4. So how can you simplify 27? Isn't it? Whole power of 4. So the final answer 12. So which means 27 whole power 4 is same as 3 power 12. Okay. So why I explain these things? because we can't leave this answer as it is. The first question, I mean, the one which I have written at the top, we can't, I mean, that's not the simplified answer or a final answer. The reason, we have a 4 and we have a 2 as a basis, which means what? We can change the basis to same basis, which is nothing but this 4. Can we write that 4 as 2 square and then whole power 21? I hope you got that. Then 2 power 35 times 2 power, so 2 times 21 is 42, right? Then you can see that we have a same basis, so you can just apply the multiplication rule, which is we're going to add the exponents. What might be the answer? 40, 75, 77. See, instead of writing this way, I mean the one which I have written at the top, so see how we simplified and we got the answer in this. So we got that. Yeah. Yep, that's it, I think. So these are the basic things. These are the instructions you guys need to follow in an exponents. So I'm done with the webinar. So please let me know if anybody has any questions. Waiting for the questions. Anybody has any questions?
No.
Okay. See, here the question is evaluate the following powers. Evaluate in a sense, so solve. So which means you need to write the answer as a whole number or an integers. So what you do here, you are going to multiply 3 5 times, okay, and then you are going to find the whole number as an answer. Similarly, so if you take this as an example, 2 power 7 whole power 0. So what will happen? 7 times 0, 0. So 2 power 0, which is 1. Okay. So let's take an example as j. Okay. So what will happen here? 2 power
4 plus 6.
4 plus 6, which is 10. That's an excellent. Okay. You might need to find the answer for that as well. And so you might have a question. Just take a look at the last question, which is minus 4 power 3. Okay, if we have a bracket or a parenthesis like this, then only this negative sign includes. Okay, otherwise we are not supposed to include. For example, there is a difference between minus 4 cube and minus 4 of whole cube. Okay, or I mean, if you want to take the different exponent, I will take, let's say 4 minus 4 power 4 minus 4 whole power 4. So that's the difference. So which means here the negative sign stays as it is. We are going to simplify only this, which is 4 times 4 power 4. 4 times 4 times 4, what is that? 16 times 16, which is 256. But in this case, you are going to multiply minus 4 you won't make these mistakes. Okay, so if you have a bracket, then only. If you have a parenthesis, I'm talking about. Yeah, hope you guys understand that. So anybody has any questions? Okay, Joseph, Thomas, any questions?
No. No question.
Okay, great, which means
No question.
Okay, which means you guys understand everything then. So I have a set of questions to try. Yeah. Just let me get rid of this. Yeah. So I have a few questions to try. So please try these questions and see. Can you see the questions? So who will answer the question, the first one? What is 4 cube? I mean 6 cube. Who will answer the first question?
216.
216.
Okay. Allow me a moment.
20.
Next is 81.
Yeah. Next one.
Next is 1 by 60.
1 by 16.
Okay. Yeah. So this is 216. This is 64. You said 81. Okay. This is 1 by 16. That's good. Then
1 by 24.
25. Yeah.
25.
Yeah. Very good. Very good, Pradeep. So what about the next one? Oh, that's you might need to multiply. Okay. So 3 times 3, 9, 9, 9s are 81. 81 times 3. What is 81 times 3?
Minus 1 by 243.
Do you think we need to add 1 by here?
Minus 243.
Yeah. Minus 243. We are not supposed to use 1 divided by, because the exponent is a positive here. That's positive. So the last one, I hope you can see the question. Minus 5 whole power minus 3. Can you see the question?
No.
No, sir.
No. Okay. Let me write it somewhere here. Yeah. The question is minus 5 whole power minus 3.
Minus 125.
Okay.
Minus 1.
But first convert this into
Minus
a
1 by
positive.
1 by 125.
minus
Yeah.
1 by 125.
Excellent. That's correct. Okay, that's good. So these are the basic questions you might know, but let's try maybe a little difficult ones. Just a moment. Yeah. So just pick the correct answer.
1.
1.
1 or 0.
1.
Okay, very good. Okay, the next one. Thomas, can you please answer the next one?
61.
Okay.
61.
Okay, because 25 plus 36 isn't it?
Yeah.
Okay. So, can you see the question? The top? X power 1 by 2.
It's
X to the power of 3.
x power by 3.
X to the power 3. Excellent. So, what about the next one?
B.
Yeah.
2y square.
2y square. Let me have a look. Gets cancelled out and, oh, that's not a correct answer. What you said? Can you repeat? Shashi Kumar.
2y square.
Can you please answer the question? Can you please answer that, Shashi Kumar?
It's A.
8y.
8y square.
Yeah. Okay. So the reason is we have a 2. So 2 power 3, then y power 2 by 3 whole 3. So this 3 cancels out. So 8 power, 8y square. That's good. Okay. So let me check if I have any. Yeah, I have a few. So who will answer the next one?
Sir, it's A.
It's A. Are you sure?
Yes.
Everyone agrees to that?
Yeah. Yeah.
Okay. Yes, A is correct answer, because 3 4s are 12, then 4 2s are 8. That's nice. So that's an interesting one. The next one. So just try to answer that. If not, I will explain.
Sir, it's B 27.
Okay. So it is a 4th root. That's what I said. Okay. 3 power 12. So what will happen? 3 power 12 whole power 1 over 4. So what is 12 by 4? 3 cube, right? What is 3 cube? So you said the same answer, isn't it?
27.
Have you answered correctly? Yeah. Okay, so let me pick the person to answer. Just a moment. Okay, so let's say Joseph, can you please answer the first question?
Okay. 1 by 5. So, 49.
Okay, so let me have a look. I don't know though. So 7 power 2. Excellent. Joseph. Okay, the next question. Pradeep, can you please answer the second question? Okay, that might be a little difficult. Okay,
Only 1 second. I'll answer.
Next question, Bharat.
but everyone can try and say the answer in chat. So that was a little tricky. So this topic I explain it later of the class. I mean, at the end of the class, I gave a
Sir,
little.
I got the answer.
What is that?
Let n equal 8.
Equals to 8. Okay, so I don't know the answer though, so I need to check. So how to solve this question? Please listen. So 2n minus 1, this is the left hand side, and I told you that, see, we have a 9 here, we have a 27. So can we make both the bases as same? Can we make this 9 as a 3? What will happen? 3 power 3 square, isn't it? And then we have already 2n minus 1. On the other side, 3 cube is 23. Okay, then n plus 1 at the top, n plus 2 at the top. Then simplify. 3 power 4n minus 2 equals to 3 power 3n plus 6. Then get rid of the bases. 3 cancels out, the same bases. And then we just need to solve this equation. Okay, let me check. I think 8 is the answer. You said the same?
Yes, sir.
Okay, good. Okay. So, Shashi Kumar, can you please answer the first one?
Yes, sir. It is a to the raised to the power of 11.
8 to the power 1. A power 11. Okay, that's very good. So who will answer the next questions? Thomas? What might be the answer for the next one?
It is 6 to the raised power 6 to the power of 3.
Excellent. So because we are going to subtract here. 6 cube, that's very nice. If you want to write it in a, 6 cube is fine, but since it's a smaller number, you can do that. I mean, that's solving, not simplification. So you need to answer this if you get a question like solve or evaluate and all, but simplification, 6 cube is more than enough. Okay, so this one is a little, just take your time, anyone can answer the next one. So take your time though. So I want the simplified answer, simplest form. You want me to explain or anybody trying?
Sir, can I answer?
Yeah.
A square by
Wait,
5b.
Repeat.
A square by 5b.
Divided by
5b.
5b. So that's excellent. So everyone understand this? How we got this? Or you want me to explain? Okay. See, we have a 15 and 25, right? So what is the common term? We can divide both 15 and 25 by 5, isn't it? So 5 3s are 5 5s are. And then we have a power 5, a power 3 in the denominator. So that becomes 3 over 5. And then we'll get a square. 5 minus 3 becomes 2. And then we have a 2 in the numerator and 3 in the denominator for b. So we'll get b in the denominator. So c by c power 4 get cancelled out, which becomes a 1. So that's why the answer is 3a square divided by 5b.
Sir,
So-
isn't b to the power of -1?
No. So what will happen? So see, this is what we have. I think you understand till this point, and then what we do, b square minus 3, and then what will happen? It becomes a b power -1 in the numerator. If we go, if we move this to a denominator, it will get b power 1. Okay.
Okay, sir. Thank you.
Yeah. So I will give one more example for that if you want. Yeah. So we'll try. I mean, let's try last one. I think that's the last one. Yeah, I think you can try that. I mean, you will get an idea if you solve this question.
Sir, can I answer?
Yeah.
X square by 9.
Yeah, right. So what you do, you are going to convert this into a positive exponent. So which is just flip the fraction, reciprocal of a fraction. I told you already. So it becomes a 2. So then you can do that. X square over 9. Okay. Yeah. I think that's it. I hope you guys understand the complete exponent questions, and we might get even tougher questions. If you want me to show, I will show you those. Yeah. Yeah. So I mean, you might get the questions like this. Let me remove my handwriting. Yeah. Yeah. So you might get the questions like this. Okay. So please be prepared to answer. I mean, ready to answer. I will share. I mean, I will inform them to share this PPT with you guys. You can try these questions in your homework if you have a time. So can anyone please answer the 13th question?
Sir, x to the power 7.
Yeah. So what will happen here? It is in the division. We are going to subtract, but we already have a -2, right? So it becomes a 5. I mean, x power 5 plus 2. X power 7. That's nice. And yeah, so this is a multiplication symbol they used here. I think in the 20th I'm talking about. So that's all. So we'll get all these types of questions. Okay, so just aware of. So who will answer the 15th one? So it's a simple one.
Sir, 1.
1.
Just 1.
Yeah. So anything power is 1. So that's the simplest one. So can you please try the 18th one if you have a time? 18th one. Take your time. Yeah. Anybody? Anyone in? Got the answer?
Sir, the answer is 4. No,
Okay.
let me try. 1 upon 16 x 4 y 10.
Okay. So you want me to explain that? Yeah, you whatever you answered is correct, but let me explain to the others as well. Just a moment. Yeah. So the question is 4x square y power 5 whole power -2. So what is a basic rule says? So we just need to convert this into a positive exponent, isn't it? So then it comes as division, I mean reciprocal of that. So 4x square y power 5, so it becomes a positive exponent now. Then distribute the exponent. 4 square x power 4 y power 10, and then 4 square becomes 16. That's it. That's the final answer. Hope everyone understands this. Yes, no?
Yes, sir.
Okay, great. So these are the other types of questions you might get, okay? Just have a look at it and see. So all, I mean, whatever the rules I have explained, the 8 rules, I think, right? Yeah. So if you know all, you can use, you can try. You can solve any of the questions, any of the exponent questions. It's very easier. Okay. So I will inform them to share this PPT with you guys, and hopefully you like the class and stay safe and take care, guys. Thank you.
Thank you, sir. Bye.
Thank you, sir. Bye.
Yes, sir.